I'm Gary Hamilton. I'm here in the Xilinx Optical Networks Solutions Group Labs in Belfast. And today I'd like to talk about the challenges that the optical transport network and communications networks in general face as we look out into the future, what opportunities that presents and what challenges we have to face. It's very obvious that the explosion of bandwidth that's occurred over the last few years has really very fundamentally changed our lives, both at home and in work. Equally, this is not a trend that's set to stop. It's going to continue, and it's going to continue for many, many years. There's a proliferation of different devices coming onto the network. So the tablets, the smartphones, these are all creating a need for a much more dynamic network. In addition to that, you've got the cloud, software as a service, you've got Hulu, Netflix. They're all driving massive demands in the network, as well as very mobile demands. All of this creates a huge opportunity for the industry, but equally there's a lot of challenges. Technologically, the challenges for the industry have always been the same. With each generation, we're challenged to do more with less. And I think as an industry, we've always responded very well to that. I guess what's becoming increasingly difficult is that the cost of doing that continues to rise with every generation. From a revenue perspective, we're also faced with some challenges in that much more of the revenue today is flowing off net rather than on net. So these traditional revenue sources that were available to us are flowing to the Googles of the world, or again to the Netflixes or the Hulus. So there's a double whammy, if you like, there, where we're challenged both from an investment perspective in that the cost of investment continues to rise, and from a revenue perspective in that we're seeing a smaller section of the pie. What that drives is a need to figure out how we do these things smarter, a more intelligent way of utilizing the available resources inside the network. Making smarter use of the network poses a number of questions. So how do we better make use of the fiber resources we have available to us, to the plant equipment that we have available to us, the human capital that we have in the industry? How do we make smarter use of all of those? Equally, we need to look at how we reduce the operational costs in the network. We need to look at how we bring more of that revenue on net. We can also look at how we can extend the life of the equipment or reduce the amount of equipment in the network by getting that equipment to pull double duty, or introduce programmability into the equipment such that it can serve many more services. Smarter networks in the OTN network, I guess the first and most obvious thing to do is to start to drive up the bandwidth. There's a lot of work going on in G709, the standards body responsible for OTN networks, to drive the bandwidth up. And we're looking at 1 terabit as being the objective. So that's a huge bandwidth increase, but that's going to drive a lot of technological changes. It's going to drive the need for smarter optics. It's going to drive the need for longer reach FEX. It's going to drive the need for smarter IP. It's going to drive the need for smarter devices. So migration is a key focus for the standard as we move forward. There's no point in having a standard which requires technology that maybe is 10 years away from development. So the standards have defined the rollout, if you like, towards 1 terabit in terms of 100 gig increments. This allows us to leverage today's technology, and equally it allows us to adopt new technologies as they come along to upscale the network. This has the real benefit of allowing us to deploy faster. The standards are also sensitive to the commercial problem that actually emerges as you increase the bandwidth. So as we head to 1 terabit, but the services are largely operating in the 10 to 100 gigabit range, they start to diverge. So historically, this wasn't a problem when the fiber bandwidth and service bandwidths were similar. But today you have the situation where a customer may only want to purchase a 50 gigabit pipe, but has to pay for a 100 gigabit pipe because that's the only bandwidth granularity available to them. This is a problem that's going to get worse as we start to head towards 1 terabit. The divergence will be huge. To overcome this problem, a lot of work has been going on in standards bodies to present the OTN network in more granular, customer appropriate bandwidth. With the introduction of 1.25G time slots, GMP, G.How, ODU Flex. These are a lot of technologies that present the network in a much more granular form to customers. The net result of this is that the network operators benefit from a much more efficient utilization of their underlying network, and the customers benefit from an on-demand pricing model. So much of the work is also focused on solving some of the equipment challenges, reducing the cost of the equipment or reducing the cost of the plant required to operate that equipment. At the most fundamental level, at the device level, we've taken great strides to increase the density per watt. That reduces the power input, the thermal output, and reduces the overall footprint required. But if we take a smarter and more network-oriented view, standards have also been emerging to allow us to reduce the amount of equipment in the network. Today's networks look very different from the networks of 20 years ago. Then there were many layers, each with dedicated equipment, all competing for finite resources in a central or local office. Today we really only have two network layers. We have an OTN DWDM layer where the coarse granularity services are managed, and we have a packet layer where the fine grained services are managed. From an equipment perspective, there is a drive to collapse these layers into single equipment. Today we find more and more routers are actually supporting OTN interfaces, but looking forward, what we're going to see is that we have a single packet fabric that's supporting OTN and packet services. The savings from this equipment consolidation, where all the layers are now being served in one equipment, is huge, both from a capital perspective and from an operational perspective. So our goal is absolutely to get ahead of the curve, both from a device perspective and an IP perspective. There's a lot of flux, there's a lot of change going on in the network, and we need to be ready for it. A great example of this is our alignment with the OTN standards. Historically, we would have found that the devices were available much later than the standards have been ratified, but today we have a 400 gigabit device already available in our Vertex 7 28nm family. These devices have the 28 gig SerDes necessary to meet the emerging standards, and they also have a performance per watt that's industry leading. Looking not too far into the future, our SSIT investment has given us the technology to create an even bigger generation of devices and keep ahead of the curve. From an IP perspective, we're continuing to expand our OTN portfolio to address the smarter network needs up to the 1 terabits required by standards. The OTN portfolio is highly optimized for Xilinx FPGAs because we know that customers need to fit all of this into a single device in order to be cost optimized. It also allows customers to continue to exploit the programmability that's inherent in FPGAs to retain their competitive advantage. These blocks are also highly optimized for Xilinx FPGAs, allowing customers to build VASSP solutions in a single device. That's going to reduce your power and it's going to reduce your footprint. By optimizing the IP for single devices, the customers can retain all the programmability advantages and still drive differentiated advantages into the devices. So hopefully with this short presentation, we've shown that Xilinx really does understand the communications industry, that we know where it is today, where it will be tomorrow, and how smarter networks are going to play a key role in that. We at Xilinx share the opportunities and challenges of our customers. We're investing heavily at many levels in the communications industry, and we look forward to partnering with you. Thank you very much for your time.